Okay, we're going to start practice programming number 3. Number 3 is a bump switch exercise. We're going to wait until the bump switch is pressed. Then we're going to turn on both motors at half power for 4 seconds. And then we're going to turn the motors off. So we're going to open Robot C. And the very first thing we're going to do up here at the top is we're going to click on Robot, go down to Platform Type. We're going to make sure that it's on VEX 2.0 Cortex. We're going to go back up to Robot and Platform Type, and we're going to turn on Natural Language PLTW. If yours already says both of those things, that's great, but it should definitely always, always, always be the first thing you check. If you don't check these two things, then everything else is going to give you problems, and it's really a very simple thing to just check right as soon as you get started every time. Once you have the platform correct, we're going to go up to File and Open Sample Program. And we're going to scroll down to the PLTW folder, and we're going to open our template one more time. Our project title is going to be Practice Programming number 3. For team members, remember you're doing this independently. If you need to ask your neighbor for help, you can. If you need to ask Mr. Hartman for help, you can. But you are doing this independently. Today's date for me is October 4th. You put whatever the date is for you. And for the section, just put your bell number. For task description, again, we're going to wait until the bump switch is pressed, turn both motors on at half power for 4 seconds, and then stop both motors. So we're going to wait until the bump switch is pressed, then turn on both motors for 4 seconds, then turn off both motors. Now again, if you need to pause or rewind any of these videos at any time, feel free to do that. That's our task description. Our task description is a sentence or a paragraph that describes our code. Our pseudocode is going to break it down into step by step. So the first thing I'm going to do is wait until the bump switch is pressed. Then I'm going to turn on the right motor at half speed. Oops, I forgot that in the task description. Turn on both motors at half speed. You guys remember what half speed is? About 63. Okay. Turn on the right motor, half speed, which is 63. Then turn on the left motor at half speed, which is also 63. Then we're going to wait 4 seconds. Then we're going to stop the right motor. And then we're going to stop the left motor. So in order to execute this code, I should have 6 lines down here in my task main. Now, something that we haven't talked about yet, sometimes maybe this symbol, this asterisk and the / gets deleted. If I do that, notice how my task main went from blue and red to green. That means it's a comment now. So technically there's no code here because everything's a comment. So if this symbol, this asterisk and the /, just like the / and the asterisk up here at the top, you see it up here? This symbol and this symbol, this is what surrounds my comment, my task description, and my pseudocode to tell me what this code is and what it's for. Remember, all this green is for humans, and the blue and red is going to be for the robot. So again, you don't need this here. And we can start pulling in code from our natural language menu. So I'm going to open up that natural language menu. Now, we haven't used a bump switch command yet. This is down here under until. And now here's a really common mistake people make. They want to do until bump or until button press. Those are different kinds of commands. We're going to use until touch because the bump switch is a touch sensor. Remember, you touch it and then it sends the Cortex a 1 signal instead of a 0 signal. When you press it, it turns to a 1 from a 0 because it's a binary sensor. So we're going to do until touch. And what are we going to touch? We're going to touch the bump switch. So until we touch that bump switch, this code is going to do nothing. Once we do touch that bump switch, we're going to turn on the right motor and turn on the left motor. So I'm going to go over here under natural language to movement, and I'm going to start the right motor. whoops, at half speed, which should be 63. And I'm going to start the left motor, also at half speed, which is 63. Then I'm going to wait 4 seconds. So over here underneath natural language in the wait category, I'm going to pull in a wait time of 4 seconds. And then I'm going to turn off both motors. So I'm going to stop the right motor. And then I'm also going to stop the left motor. Now, if I've done this correctly, my pseudocode and my actual code should pretty well match. I'm going to add the comments, so I'm going to hit tab a couple times to get over, and I'm going to hit 2 forward slashes. Notice how they turn green. That's how I know it's a comment now. So I'm going to wait for the bump switch to be pressed. Then once that bump switch is pressed, I'm going to turn on the right motor at half speed. And then I'm going to turn on the left motor at half speed. And if you noticed in sample code number 2, practice programming number 2, when you turned on both motors and you did the right motor first and then the left motor, did it look like they turned on at the same time? It should have. It should have looked like they turned on at the same time because code processes in microseconds. So it happens faster than even a split second. That it reads one line of code, then the next line of code. So it doesn't really matter which one you turn on first or second. It's going to look like they both turn on at the same time. This line of code is going to wait for 4 seconds, and then we're going to turn off the right motor. And it's the same thing with stopping the motors. It doesn't matter which one you stop first or second. It'll look like they both stop at the same time. So now we've got our code all finished up. We've got task description, pseudocode, our actual code, and comments for each line of code. And again, all of these things are required if you want all your points for your code, because that's what a proper code contains. It contains all these things. The last thing we're missing is motor and sensor setup. Now, we have to tell the robot where the motors are going to go. And remember, we don't use port 1 or 10. You can use any of the other ports 2 through 9. I'm going to use port 2 and 3. If you want to use ports 5 and 6 or 7 or 8 or 3 and 9, it really doesn't matter. As long as you tell the robot which ports you're using, tell the robot you're using VEX 393 motors, and then of course you have to plug the motors in the correct place. Once I tell the robot that I have motors in port 2 and 3, I better actually have motors plugged into ports 2 and 3. And don't forget, you can't plug a 2-wire motor into a 3-wire port. You have to use this thing. What's this thing called? A motor controller. That's right. It's called a motor controller. So you have to plug in the motor controller to the motor, match up the red wire to the red wire and the black wire to the black wire. And then when you plug it into the Cortex, make sure you're in the motor ports and plug it into ports 2 and 3, because that's what I told my code I was doing with the black wire on the outside. Now, we have to tell the robot that something else is plugged in. What else are we plugging in? We're plugging in the bump switch. Do you remember what type of sensor that bump switch is? It's a digital sensor. So up here at the top where it says, we have a couple different menus, it's not an analog sensor. If you program it as an analog sensor, it's not going to work. You have to program it as a digital sensor. I'm just going to go ahead and put it in digital 1. A bump switch is a touch sensor. You have to tell it what kind of sensor it is. It's a touch sensor. So when I hit apply and OK, this is a really common mistake. If I look up here under bump switch and it says no sensor, let me show you what that looks like. If I forget to tell it that it's a touch sensor and it says sensor none up here, this is a mistake. Your bump switch isn't going to work. Your whole code is going to look like it doesn't work. So when you do your bump switch setup, you have to remember to tell it that it's a touch sensor, click apply, and up here in your Pragma, you'll see that in digital 1, this is not digital 11, it's DGTL1, bump switch, it's a touch sensor. When you compile your program, you should not have any errors, and you're ready to download this to your robot. So make sure that everything's plugged in properly, and good luck with your code number 3. Good job, guys.